Okay, so let's continue with our next coding exercise series. So open the leetcode.com and go to the problems tab. And in the search bar, search question number 209. So the question is minimum size sub array sum. It's come under the medium category. So click on it. So let's read the question. So minimum size sub array sum. So given an array of positive integer num. So we have some arrays given, or in the Python we can say some list is given, right? Okay, and all are the positive integer, so there is no negative integer, which is fine. And a positive integer target. So we have two things given. One is array and one is some integer is given. So if you see, two inputs are given, this array and one integer is given. Okay. Return the minimal length of a sub array whose sum is greater than or equal to target. If there is no such sub array, then return 0 instead. So what we need to do, so we have some arrays given. Okay, we need to found, okay, like what is sub array? Sub array is the part of that array. Like, so it could be 2 3 1, or it could be 3 1 2 4. Like, it could be the part of the array. So we need to found that sub array whose sum is either equal to 7 or greater than equal to 7, or greater than 7, right? Then we will calculate the length. So there could be many possibilities. So we need to find the minimal length. So as an example, so if we go 2 3 1 2 4 3, so how we can get the sum? So one sum is like this, said, okay, 4 plus 3 is equal to sum. 4 plus 3 is equal to 7. So one is this array. So length is 2, right? And what was the other array? So 2 plus 3, 5, 5 plus 1, 6, 6, 6 plus 2, 8. So this is also one of the array, because we need greater than or equal to target. So 8 is greater than or equal to 7, which is fine. So this is one array. So length is 7. So this could be another array. 3, 3 plus 3, 6, 6 plus 4, 10. This is again for length 4, right? Uh, but the shortest one is 4 and 3. So how we are going to calculate that? So we found, okay, shortest length is 2, so we need to return the integer. So if you see the function definition, so we have some arrays given, nums, we have some integer is given, and we need to return the integer. Okay, so let's look at the second example. So 1 4 4. So they said the target is 4. Okay, so target is 4, so 4 we found. So sub array could be single element, so output is 1. So if we see 11, so 11, even if we add everything, still we can't achieve 11. So in that case, we will return 0. So they said if there is no sub array whose sum is greater than or equal to target, just return 0. All right. So how we are going to solve this problem? So let's go to the whiteboard. So one easy approach is to run two for loops. So as an example, so just look at this left hand side. So where we have the array 2 3 1 2 4 3 and the target is 7. So one easiest approach is, let's keep the two constant, and then just like we have two for loops. So one for loop, and then the second for loop. So for the first for loop, so one element will be constant, and the second for loop, it is going to scan all the elements. Then in the next loop, so I will move here. So in the first for loop, so j is equal to 2, so sum is 2, but we need 7. Okay, then we will move j here. So j is now 3. So 3 plus 2 5, but we need 7. Now we will move here. Okay, so 3 plus 2 plus 1 6, but we need 7. So we will move j here. Okay, so 3 plus 3 6 plus 2 8. So we found 8. All right, so we found 8. So our length is till now is 4. So shall we move forward? No, we are not going to move forward, because we already found that array. So we are going to break the inner loop. So we are not going to move further, because all are the positive integer array. Because in the question it is mentioned positive integer array. Because if we move forward, anyhow you will get the sum greater than or equal to target, but the length will be more. Length will be definitely more than the 4. All right, but we need the minimum length. So one we get 4. Now we will move I here. We will move I here. Okay. So 3 plus 3 6. All right. So now we will move j here. Okay, so 6, 3, 3, 6 plus 4, 10. So still we are greater than 7. So we will found one more length, that is 4, but it is still same than the 4. So we will again break the like the inner loop. Then we will move here. So now 4 plus 3, 7. Right. So now we found 7. So 4 plus 2 plus 1, 7. So now we will found so the length is 3. So which is less than the previous length. So previous we will get some array, some sub array whose length is 4, but now this time we'll get like 3. So we will consider 3 as an option till now. So we will break. So now we will move I here. So 4 plus 2, 6. So it will not equal to or greater than target. So now we will move forward. So 4 plus 3, 7, 7 plus 2, 9. So still greater than equal to 7. So the length is 3, but it is still same as the previous answer. So now we'll move I. So 4 plus 3, 7. Yes, we will like found that array. And so the length is 2. So this could be the new answer because there is the minimum. So now we will move I. So now it is 3 only. So which is less than 7. So we will get the our answer as a 2. So one approach is to scan all the possibilities. So first try this solution, whether this solution is going to be accepted by our lead code or not, which is a straightforward solution. Just scan all the elements. So what we have to do is, so n is equal to length of nums. Okay, so we need two for loops, right? So for I in range of n, okay, for j in range of I to n. So because if j will move here and if I will move here, then we are not going to start from j here. Then if j is here, then j will start from here only, because there is a one more sub array. So because you can consider I the starting point, j is the ending point. So one is this ending point. So you can't say like starting point is 3, end point is 2. So that's why whatever is the I at this point, so that could be the starting point. So that could be the starting point. Okay. So now, so once we are here, right? So we are here. So now we found the sum. Okay, what is the current sum? So currently j is here. What is the sum? So sum is 2. So once we found the sum, we will compare with the target. So let's take one variable, because sum is going to be changed in when the I is going to move. Sum is going to be changed. So current sum is equal to 0. Okay. So now what is the current sum? Current sum is equal to current sum plus nums of j. Okay. So because I is constant, so j is 2. So current sum is 2. So let's check if current sum is greater than or equal to target. Is it greater than equal to target? No. So is it not greater than equal to target? So then our loop will, because it will not go into the if condition, and then j will increment. So j will increment. So j will come here. Now our current sum is because we are not resetting the current sum. So current sum is 2. So now 2 plus 3, 5. So current sum is 5. So is 5 is greater than 7? No. So it will move again further. So now the current sum is 3 plus 2, 5, 5 plus 1, 6. Is it greater than target? No. So it will move further. Okay, it will move further. So now the sum is 2 plus 3, 5, or 6 plus 2, 8. So is it greater than target? Yes. Yes, it is greater than target. So if it is greater than target, what we have to do? If it is greater than target, we have to find the length, minimum length. Okay, till now what is the minimum length? Minimum length. So we will take one more variable, min length, and in the starting we will say minimum length is infinity. That is the maximum. Okay. So how to calculate the minimum length? So whatever the earlier minimum length, so earlier is like some infinity, or maybe you can say 99999. So any number, like, or let's say infinity. So we find the minimum. So minimum of whatever the earlier and whatever the current. So current is j minus I. So current is j minus I. But if you subtract j minus I, so j is 0, 1, 2, 3. So 3 minus 0, 3. But the length is 4. So that's why you have to add plus 1. Okay, so minimum length is, so we found the minimum length. Okay, now, so you found that. Do we need to move j further? No. So we have to break the inner loop, because if we move j further, if we move j further, we are going to get this condition satisfied, but every time minimum length will be the earlier minimum length. So unnecessary, don't need to run the loop. So we are going to break. So we are going to break the inner loop, but the outer loop still will run. Outer will still be run. So it is outer. Now the I will 3, right? So then again J will going to start from here, right? So then it will again find, and everything going to find. Now at the end, so we will check if, let's suppose we could not find the minimum length, because there is one example where we could not find the minimum length, right? So this example. So in this case, so minimum length, if minimum length not equal to not equal to float of infinity. So if minimum length is not equal to infinity, it means we have updated that variable. So return minimum length. It means we have updated with variable. Else return 0. So if minimum length is equal to float of infinity, then return 0. So let's try to run that code. So our sample case has been accepted. So let's try to submit. So it is taking huge time. So definitely it's going to fail. Fail not because of the logic, but probably because of the timeout issue. Okay, yeah, as expected, it failed with the timeout issue because of the very large input. If you see very large input, so 18 test case passes, but out of 21, but still like 3 test cases like did not get passed. Okay, so it means Leetcode is not accepting our this problem, this solution, but this solution is correct. As a starting point, this solution is perfectly correct. Okay, so do we have the another approach? Yes. So whenever the tour for loop doesn't work, now then think about the two pointer approach where we are moving both the pointers parallelly. So now this approach is not working. So let's move this sliding window. So even here as well, you can say we are using two pointer, but here two pointer because we are again resetting j. So we are not moving I and j together. So but here in the sliding window, so we are going to slide, because once r will reach here, r will not going to reset at the same level. But here, because I is here and j reaches here. Let's suppose not here, but j reaches here. And when I was here, we are again resetting j. We are again resetting j. All right. But in the sliding window, so once j will here, so only the I is going to be slide. J is not going to be slide. So a little bit less time. So a little bit less time. So let's see the sliding window approach. So how the sliding window approach will. So it's the same approach. We will take two variables, left and right. Similarly, I and j, both I and j on the zeroth index. Similarly, left and right on the zeroth index. So let's take the left and right element. So left is equal to zeroth index, right is equal to zeroth index, n is equal to length of nums. All right, and the minimum length as well. Minimum length is equal to float of infinity. Okay, so left, right, and minimum length. So we take the four variable. Now what we have to do, and you can say the current sum as well. So current sum equal to 0. Okay, or even you forget for the time being. Okay, so now what we have to do, so we have to run a loop. Okay, because we have to scan the element, so we have to run a loop. So now what we will do, so because here I and j were there, so what we are doing is we are in the current sum, we are adding the nums of j. So similarly here, we will move our right pointer, we will move our right pointer until we will not find the sum. So we need to move around until we find the target as a sum. So we will move the right pointer. So let's move the right pointer. So while right is less than n, so we are going to move the right pointer. Okay, fine. So we are going to move the right. So now right is here. Right is here. So right is starting 0. Is 0 less than whatever the length of 1, 2, 3, 4, 5, 6? Yes. Is less than 6? Yes. Okay, let's calculate the current sum. Current sum. Current sum is equal to current sum plus nums of right. Nums of right. So we find the current sum. Okay. As soon as we found the current sum, what we have to do? We have to compare. Similarly, like earlier as well, we are comparing. So if current sum is greater than equal to target. So if current sum is greater than equal to target, if current sum is greater than equal to target, what we have to do? We have to find the minimum length. So minimum length is equal to mean of whatever the earlier minimum length, and then similarly right minus left plus one. Similarly, like I minus j plus one equal to one. Okay, now we find the, so let's suppose, okay, let's scan. So r is equal to 2, right is at 2. So let's find the current sum. So current sum is 2. Is it like greater than equal to 7? No. So we will move r. So we will move r. So we have to move r. So right is equal to right plus 1. Because if current sum is greater than equal to target, it's not. Let's move r. Let's move r. So we have moved r. So now r is here. So okay, what is the current sum? 3 plus 2, 5. Is 5 is greater than 7? No. So let's again move r. So r is here. Okay, 3 plus 2 plus 1, 6. So is like some current sum is greater than 7? No. So let's move again r. So now we will move r here. We'll move r. Okay, now 3 plus 2, 3 plus 2, 6. Sorry, 3 plus 2, 5, 5 plus 1, 6, 6 plus 2, 8. Okay, now we find the current sum. So as soon as we find the current sum, what we will do? We find the current sum. We find the current sum. Now we are going to move L. Now we are going to move L. So, but before moving L, because current sum is 8. If we move L, we need to decrease, we need from the current sum, we need to subtract this 2 as well, because now the current sum will be between these elements. So as soon as we find the current sum is greater than target, so now in this case we found, so let's calculate the length. Length is 4. So now length is 4. So let's calculate the current sum as well. So current sum is equal to current sum minus nums of left. Nums of left. So basically we will like subtract this element and we will move our left pointer here, right? So because we are not resetting our right element, so let's move. So now left is equal to left plus 1. So we will move our left pointer. Okay. So we move our left pointer. So what next? So as per this logic, we just move our left pointer, but we will move our left pointer and that's it. And then again, we are increasing our right pointer. Again, our increasing our right pointer. All right. And in this case, like we are doing this. But if you see this example, 1 1 1 1 1 7 5, and let's put the target is 9. And if I take left pointer here, and if I take right pointer here, all right, so let's take this example. So in this case, if we do like this, and if we do, and if minimum length not equal to float of infinity, then return minimum length, else return 0. All right, so for you this logic looks correct only, right? Definitely correct. But if you see this approach, then logic seems a little bit wrong. Like how see? So currently right pointer is here. So sum is 1. Is it greater than 9? No. Is it greater than 9? So no. So this loop will skip. Now we will do right is equal to right plus 1. So we did right is equal to right plus 1. Sum is 2. Is it greater than 9? No. So we will again do this. Sum is 3. Is it greater than 9? No. We will move R here. So sum is 4. Is it greater than 9? No. We will move R here. Sum is 5. Is greater than 9? No. So now we will move R here. So now 7 plus 5 is equal to 12. So 12 is greater than 9. Yes. So 12 is greater than 9, which is okay. Now we know we need to move the left pointer because we found the sum. So definitely let's move the left pointer. So we are moving left is we are first subtracting. So first 12. So okay, we subtract 1. So 12 minus 1 1, and we are moving left pointer here. But as soon as move left pointer here, all right. So we are not checking because this is 12. But so when we are here, we found one window. So 1 2 3 4 5 6. So length is 6, which is perfectly okay. But if we are moving here, are we checking whether still it is the valid or not? Are we still checking? Because in this case it is still valid, because now the sum is 11, which is still greater than r. All right, so we have to update our minimum length as well. even if we still move r, it is still valid. Even if we still move r, it is still valid. It is still valid. So we have to keep moving left until the current sum is greater than target. So instead of if, we will do while. That's it. So while current sum is greater than equal to target, so current sum is greater than equal to target. So we will move. So we will move r. Is it still greater than? Yes. Let's decrease the window size. Is it still greater than? Yes. Yes. Let's decrease the window size. Is it still greater than? Yes. Let's still decrease the window size. So let's still decrease the window size. Now it is not greater than, so now we have to increase the R. So now we will again check, but we already found the length of 3. Or maybe like 7 plus 5 is equal to 2. 7, 5, 12. So the length will be 2. So in this case, like we have to, instead of if loop, we have to do the while loop. So let's try to run the code. So our sample case here has been accepted. So let's try to submit. So our solution has been accepted and we beat 44% of the people and memory as well, like 45% of people. So earlier when we run two for loop, it was 18 test case even still pass, but like 2 3 test cases still fail. But now if we use a sliding window approach, like approach is still same because here we are moving I j, but again here we are resetting j. But when we reach here in the sliding window r here, we are not resetting. We will keep decreasing the left hand side. We will keep decreasing the left hand side. So until the sum is greater than target, we will keep decreasing the left hand side. Decreasing means like moving to the right. So left is equal to left plus 1. So that's it. That's the end of the video. Thank you. You can also try this question. Thank you very much.